Hello? Hello? Hello?
Hello, can you hear me?
Sir, good morning, sir.
Good morning. Can you hear me?
Yes, sir. Yes, sir.
Okay. Am I audible?
Yes, sir.
Hello?
Audible, sir.
Sir? Vinod, sir?
Yes.
Can you hear me, sir?
Yes, I can. Shall I share my presentation?
Sir, just a minute, sir. We have a formal introduction and welcome, after which you can share it a few minutes.
Okay. Because, you know, I'm not so familiar with this Google Meet. I haven't used it.
Okay, sir. Good morning to everyone. So I would like to welcome you all to the International Conference on Smart Technologies and Applications 2022, conducted by Ramco Institute of Technology. And this session is about an invited talk on the blockchain methodologies. And now I call upon our student, Ms. Rajalakshmi, to deliver the welcome address.
Good morning, one and all present here. On behalf of Ramco Institute of Technology, I would like to express my great pleasure in welcoming all of you for the AICTE-sponsored International Conference on Smart Technologies and Application, ICSTA 2022, supported by Department of Biotechnology, National Bank for Agriculture and Rural Development, and Builders Association of India. I feel glad to welcome Dr. S. Perinayagi, Professor and Head, Department of Electronics and Communication Engineering, Ramco Institute of Technology. I would like to extend my warm welcome to all the conference participants, research scholars, faculty members, and the students of Ramco Institute of Technology and other institutions. Just before we get started, I would like to express my gratitude to the chief guest, Dr. Vinod Pangratius, Associate Professor, Department of Electrical Engineering, for accepting our invitation. On behalf of Ramco Institute of Technology, I gladly welcome you to this International Conference on Smart Technologies and Applications 2022. We feel very grateful to have you on this great occasion, sir.
Thank you very much.
Thank you, Rajalakshmi. Now I call upon Ms. Shruti to provide a small introduction about our chief guest.
Dr. Vinod Pangratius is working as an associate professor in the Department of Electrical Engineering and chair of the Department of Electrical and Computer Engineering, School of Engineering at American University, Dubai. He completed his PhD in Electrical Engineering at Sorbonne University, Paris 6, France. He earned his MTech degree in microelectronics from the Indian Institute of Technology, Bombay in 2001 and completed his BTech degree in electronics engineering from the Cochin University of Science and Technology in 1995. He has a very rich industrial experience in various semiconductor industries like Cypress Semiconductor USA, Infineon Technologies Germany, and Innovative Silicon Switzerland. He joined American University Dubai in the fall of 2014. His teaching and research interests include digital hardware development, microprocessor system architecture and design, three-dimensional integrated circuits, VLSI, EDA, field programmable gate arrays, system on a chip, and application-specific integrated circuits. He has published more than 50 papers in reputable journals and conferences. He has also served as a reviewer, review committee member, technical program committee member, program chair, organizing committee member, and steering committee member for multiple international conferences and journals. He has regularly reviewed papers for several journals, including the IEEE transactions on nanobioscience, IEEE transactions on CPMT, components, packaging, and manufacturing technology, and IEEE transactions on VLSI systems. Dr. Pancratius is a member of IEEE and ACM. He is the chair of the IEEE CAS, WSCS, and PELS UAE chapters. He maintains strong connections with the semiconductor and software industries in the UAE and the Middle East.
So thank you, Shruti, for this brief introduction. Now I hand over the session to Dr. Vinod for delivering a lecture on our future with blockchain, cloud, and peace engineering. Sir?
Thank you very much.
Thank you, sir.
Thank you very much for that wonderful introduction. And today I will spend some time with all of you, introduce few things about new technologies, which connects, the the aspects of blockchain, artificial intelligence, machine learning, and all connected technologies that we learn through our courses. Let me try to share my presentation. I need somebody to help me with that.
Sir?
Yeah, I would like to share my presentation.
Yeah, sir, can you see a up arrow in your icons? We have a raise hand symbol and up arrow present now.
There is a raise.
Yes, in the bottom. In
the bottom, sir.
Yes.
Near the raise hand, you have an up arrow.
Microphone. Second one is video, sir. Third one is caption. Fourth one is the hand. Symbol.
Raise hand.
Yeah.
The
fifth
near one.
Okay.
There is an up arrow, sir. Kindly click that. Then your entire screen. There is one option. First
Oh,
option.
yes, I got it. Yeah. Thank you very much.
Thank you, sir.
So can you see my screen now?
No, sir. Yeah. Yes, sir.
Yes, sir.
Okay, very good. Thank you very much once again. So I'm Vinod Pancratius, and I'm also the chair of Electrical and Computer Engineering Department at American University in Dubai, as the person who introduced mentioned. So this is American University in Dubai. As you see here, it's a wonderful campus in the heart of Dubai. It's very close to the place called Jebel Ali, or you probably heard about Internet City in Dubai. It's basically in the heart of Internet City. And we do have different programs in our university. So please, if you want to learn more about AUD, you can visit our website, aud.edu. So that's the presentation overview. Basically, the normal, in a traditional way of introducing an overview is to give you some bullet points. But here I have a word out, because I know I'm going to talk to a lot of undergrad and graduate students. I believe my audience majority are undergraduate students, like BTech students. Am I right? I hope so.
Yes, sir. Yes, you're right.
Okay, so that's why I did this, because the undergraduate students in the current stream have to learn a lot of new aspects beyond your curriculum. So I put these terms, which probably you're familiar, some of them, maybe you heard about it. through different research programs. Decentralized ubiquitous computing, machine learning, artificial intelligence, innovation, blockchain, deep learning, reinforcement learning. All these are different aspects of terms that are getting more famous and familiar with student community as well as the industrial community. So we'll go on discussing few terms from this. I'm not going to go into details of everything that is being mentioned here, but we'll spend some time to understand what are these terms and how it impact our life as a technology, as a student, as an industrial person, how it impact our life. And in this presentation, I'm going to focus on 3 Ds. The first D is digitization, which is the widely accepted term. It's being taken up by different industries, academics, as well as different economies, like developing and developed as well as developing economies. Digitization is a big term today. So we'll try to understand what exactly this digitization means. And then we'll also try and understand what is decentralization. And the most important aspect of our life is decarbonization, right? So we as students, we are all responsible towards the earth which we are living in today. We have a responsibility to make the place we live as a beautiful place and a better place for our new generation, young generation to enjoy this earth. So I'll educate about students in their responsibility to make this place a better place for all of us to live together. Digital economy or digitization. Digitization of the world leading economies. Basically, this is a true fact today that the Indian government, also the UAE government, if you just take any South Asian or European governments, they're all spending a lot of investment into the field of digitization. Every aspect of our life is revolving around a digital economy. You don't have to, for probably 10 years ago, we need to travel to different places to do a lot of things. For example, paying bills or paying taxes or meeting somebody. Everything can be done from home now. So it's mostly everything is on the internet. We are doing a lot of activities on the internet. The government spending and investing a lot of money. So it's a big opportunity for student community to learn more about digitization, how it impacts your life. You're already experiencing, and I don't have to talk more about it. And the second, datification of industrial and commercial sector. Datification is not a word actually, but I introduced it. Datification means wherever you go, you're being datified because your actions, your every actions and every events you participate, a lot of data is being collected from you without your knowledge. Maybe you're already aware of it. For example, if you are in a textile shop, you want to buy a few nice dresses. And then you go inside the shop, you walk around and you try to find which dress that suits the best for you. And then you pick few. And that basically the entire shop is monitored using a camera, multiple cameras around the shop. So they capture every moment of you inside the shop. Likewise, they get data for maybe the shop starts at 10 a.m. today morning and until it stops at 8 in the evening or 10 in the evening, 10 p.m. in the evening. And this data, the entire data that's being collected, which is basically a video information, right? And then at the end of the day, there is an automatic program, an autonomous program, which go through the entire video streams and try to figure out which dress you or anybody 10 or 20 people pick the most. And then the next day, the mannequin in the shop wear the same dress. So that's basically a kind of marketing idea that's being used by an industry to collect information and use that information to figure out what is the best way they can market themselves. But the foundation and underlying technology, as an undergraduate student, learning more about electronics, electrical, and computer engineering, The fundamental underlying technology which you learn and over the course is network systems, connectivity is a very important factor, computational power and storage. Sorry. So networking is an important aspect in your learning. You learn a different kinds of networking, connecting computers or connecting systems together. And then connectivity, the net connection, you're connecting different applications, right? Connecting different devices, whether it's a high power systems or a low power systems, it doesn't matter. Every system has a connectivity, and that generates a lot of information throughout the connected time it is connected. And the computational power, for example, you all probably carrying a cell phone today, and most of your phones are very high power phones, which probably have more than one core, like maybe dual core systems or quad core systems. It can run multiple applications. So these are very powerful systems which you have in your hand. And also the storage. You have a large storage capacity. When I say storage, it actually involves memory as well as your hard drive. So you have a large memory storage capacity, a large hard drive capacity. You can store a lot of information which you generate over time. Every time when you log into Facebook or LinkedIn, you actually generate a lot of data. And you provide a lot of information for free, right? You don't charge anything. Your personal information, a lot of personal information you are giving for free to people. And these informations being used by the companies to generate data models. And then every application you receive from these companies are basically generated from the data you provide to them. And that's basically improved business to business, business to customer interactions, which is another aspect of datification, where these companies trying to improve their productivity by increasing their spectrum of communication and interaction with other customers. So they don't have to come to you, they can just connect with you and interact with you. You probably receive a lot of calls every day asking for this and that. And sometimes they ask for some kind of opinion. So they create a poll, try and understand what is the best product, what is the best way they can customize the product for you. These are, apart from all these, sometimes it is good, sometimes it's bad, but as far as a student is concerned, these are opportunities. It triggers new innovations and entrepreneurship among you. It is actually very, very important as far as a student life is concerned. Maybe 10 or 15 years ago, maybe 10 years ago, 5 years ago, every institute in India and across the world is to graduate students. And then once you graduate, you are in the market trying to find a job, some trying to find higher education institutions to continue their education. Sometimes students try to find job. But we have a policy in AUD that we do not want to graduate students. We want to graduate companies. So sorry, 1 second. We encourage students to come up with ideas, innovative ideas, and then start initiatives called entrepreneurship initiatives. Encourage you guys as well. Think about your future, not as a job seeker, but a job provider. That's the way you should model your undergrad time. You'll have 4 years or maybe 5 years at the most. You're going to spend in the university, spend it effectively in a way that you become one of those job providers. So new innovations and entrepreneurship is an important aspect. The university itself should become an incubator for students to test and develop their ideas. So there are a lot of different ways you can do that. You can improve the productivity of an existing product. You can improve the productivity of an existing service. New business models can be generated from any idea. All ideas are welcome. There are no ideas which are not good enough, okay, in today's world. So I encourage students to come up with any idea. It doesn't matter. Sometimes it may not be engineering ideas. Okay, it could be a business model, but later you can turn it into an engineering idea as well. Technology transforms information. It's also important for you to understand the technology behind everything that I mentioned. Few interesting aspects of different technologies that's being used here. There are ubiquitous computing, pervasive computing. These are computing aspects that need to be discussed in the undergraduate curriculum, but we don't discuss much about these. Artificial intelligence, cyber-physical systems, machine learning, deep learning, blockchain, robotics, and robotic process and automation. Okay, but the basic technologies which you're going to learn through your curriculum as embedded system technologies, communication technologies, networking technologies. I only mentioned a few here, but you learn a lot, isn't it? This is your foundation. You stand on this foundation and then you can go beyond the foundation, learn more about it. All these are on the tip of your finger that these technologies are available. Ubiquitous computing means, as you see today, you have a cell phone in your hand. When you go into the computer lab, you have computers in front of you, but maybe after some time, all this will disappear. We call it disappearing computer, right? With the development of artificial intelligence, natural language processing, you could talk to artifacts. For example, in your table, you can integrate components in your table that listens to you and take action based on what you talk to them. Imagine this world where every walls listen to you and take actions based on what you're talking to them, right? Isn't it amazing? That's the style which we are moving in. But apart from the complexity involved in these technologies, what you guys should think about it, it's an opportunity for you to learn more about it, invent and becomes an inventor in this time frame. Digital transformation. I just put a few facts about UAE because I'm living in the UAE for maybe last 7 to 8 years, and I learned a lot about this Middle East countries, right? Because our focus is more towards Middle East countries. As far as our university is concerned, we get very few students from India. So technology transforming the nature of work and reshaping the economy before our eyes. You know, actually, UAE is one of the finest countries in the world where they've been using technology to modernize the way the country performs in terms of every citizen who live in this country. 90% of the UAE population are expatriates, and only around 10% are the ethnic UAE citizens. And we still feel the impact of the government in our life daily. When we go to anywhere, when we travel, when we meet people, you know, the impact of the development of different technology that connects with us, it's very much alive here. So that's why I say digitization is an important aspect. It's been started in India, but we haven't, you know, reached a level we can say that it is impacting your life. Probably yes, to some extent, but we have a long way to go. UAE has more than 100% smartphone users and over 70%, which is a number a few months ago, but hopefully this number may have increased from this point. Consumers are ready to lead a digitally enhanced life. What is the meaning of digitally enhanced life? Which means you can do a lot of aspects, which you probably spend a lot of time in doing it earlier. It saves a lot of time. You could sit at home and then perform a lot of actions, a lot of work being done at home, right? You can also, you can sit at home and do a lot of your activities that you probably used to perform by sitting in your office. You don't have to be in the office, means starting from 9 to 6, you know, you can spend some time home and come to office when you need it. So all these are initiatives that's being introduced to improve the quality of life of citizens in our country. So well-defined digital initiatives are a requirement today. So the government or the country itself have to come forward and define these digital initiatives so that the population or the student community, the societies can work together to develop applications, programs that support society. We call a social machine, developing a social machine that supports and development of a society, right? It's critical for developing economies. I mentioned developing economies. Most of the South Asian countries are developing economies to initiate the process of innovation and entrepreneurship programs in a digital platform. Because it's what I found in AUT that we have an entrepreneurship and innovation center, which I'm also part of it. So there are many companies already graduated, around 6-7 companies. It's only like 2 years we started. Around 6 companies graduated from our incubator already. So the culture of innovation and entrepreneurship means providing a mindset to the student community. It's not that you can, when you graduate, you probably very successful in finding a job with certain figure salaries and all that, but you will be more satisfied. Your mind, the things you learned, sometimes gives you more satisfaction when you feel that you are now your own boss and you can provide employment to certain people, right? So that's a different feel, and I would like you to think, all of you, to lead all of you to that's the time in today. Need for innovation. So if you think about trying to innovate something, you also have to understand what are the different categories of innovation. There are different kinds of innovation. Every innovation is are welcome. And sometimes these innovations help in different people, different ways. So they are called, the Clay Christensen is a professor from Stanford University. He identified 3 different kinds of innovation. The first category is called sustaining innovations. Sustaining innovations helps to establish organizations survive in the face of changes in their environment. It's very important. Because in our eyes, we have seen from our experience, a lot of companies who did not pay attention to the changes in their environment have been, didn't grow as it's supposed to be. For example, Nokia, you know what happened to it, right? So sustaining innovations are very, very important. Maybe some of you might come from a business background. Already you have business running, because that's more relevant in UAE. A lot of families run business here, and students come from business background. Similarly, I know Chennai is also a metropolitan city with a lot of different business runs. So students might come from business background. If you already have a business, you have to think about this. How are you going to sustain your company or your business based on the changes that happens around you? Maybe somebody who is just starting today going to run over you after some time if you're not careful enough about your business. Second is also an important innovation to consider. Energy producing innovations create significant departure from established structures and processes, basically a kind of innovation that improves the productivity of your business. Maybe to develop a product, you take 2 days or maybe 2 months, but you have to invent ways to reduce that cycle time. Maybe 2 months reduced to 1.5 months. You save 15 days and you are ahead, right? So it's also it's important to come up with such innovation. So we are encouraging our students to think about in different ways they can improve their productivity as a student. How do you manage your time? You get assignments, you get quizzes, you get exams. Are you ready? Anytime if I ask you to, I go to class and I give them a quiz and I don't give any indication before that you're going to have a test today, the students have to be ready. Are you ready like that? So that's your efficiency, how you manage your time, how you improve your productivity. When it comes to an industry, it's a very important question, right? The third category is very important as well, but very few innovations of this category. Disruptive innovations result in fundamental changes in the structure and nature of the whole sector. There are many examples. For example, I'm not sure students know the floppy disk. We used to have sometimes in the 90s, floppy disk. And the floppy disk was disrupted by CD drive. And do you have CD drive today? It was also disrupted by the solid state, isn't it? So these are innovations that sometimes it stops the cycle or the path of certain product, and then you take over. That's third category of innovation. So keep in mind about when you think about an idea, or sometimes you have an idea and you can categorize into which category I belong, and then it helps you to improve your idea. What you can do as academics, I'll talk more about the academics, the professors who are listening to me today, you have to think about this. Accelerate comprehensive and mutually reinforcing innovation using advanced digital technologies. Establish a digital ecosystem, which is very, very important, a digital ecosystem in your institute with a synergy of artificial intelligence, machine learning, blockchain to accelerate innovation and entrepreneurship programs. Because these are new technologies and new ways to improve the productivity, efficiency, and also disruptive ideas. The students are source of ideas. They have huge imagination, great imaginations. And out of their imagination, great ideas will form, and that can be transformed if you provide an ecosystem for them to grow. Develop new technologies and standards using the concept of decentralization in the industrial sector, such as energy, health, finance, and e-mobility. These are emerging industries. Energy industries being there, right? We get energy from a centralized energy provider, which we have already in India, right? It's widely advanced and widely used technology, but it's going to be transformed very soon. I'm going to give you some hints about it. Health industry, a lot of different health institutes, advanced health institutes, especially in Chennai. Finance industry and e-mobility. A lot of ideas can be developed in e-mobility, electric vehicles, which is very much part of the decarbonization. We don't want fossil fuels, right? There are economies runs on fossil fuels, and we don't want it anymore. We want to move it out, phase it out, and make this place a better place for us to live. And the first thing we need to think about it, how we can phase out this fossil fuel, the use of fossil fuel. Develop and design decentralized applications, infrastructure using artificial intelligence, machine learning, and blockchain. These are three main categories. We need to think about how we can utilize them. To utilize them, we must learn very well what are these and how these can be used. None of these are taught in the universities, so don't expect your professors to come and teach you about this. It is your responsibility as a student to go beyond your curriculum and learn about these things. Sit in your lab, take a book, sit in the lab, practice it. That's the only way you can learn it. Digital transformation is possible if you establish a decentralized forum of participation for all stakeholders from the government sector, individual agencies, academics, and civil society. So we need to come together as a forum to discuss about this, set standards, and help our student community, the technical community, to grow and understand more about these technologies. Decentralized applications, decentralized data, decentralized processing power, decentralized algorithms, and decentralized modeling concepts. So everything is decentralized. Nothing is decentralized as of now. It all runs on a centralized platform. But soon we will decentralize it. What is the decentralized data means? I hope, in the UAE, every home has more than one computer. Everybody works and students also have laptops. So these, and everybody then, when they start using it, they generate a lot of data that's being stored, which is called a privately held data. Okay. Some of it are private. They don't want to disclose it to anybody. Fine, good enough, keep it. But they also have public data. They put certain information in the public domain. So we can use them, right? But we can also use the privately held data. I'll tell you how. The second is a processing power. And these machines you have at home, for example, if you take the Chennai city, somebody should do a research. How many homes they have at least one laptop? Maybe more than 80%, I believe. I'm not sure. You can try to find out. If more than 80% people or 80% homes have a computer, which means it's a very, very interesting area to start working in. This means every home can work as a decentralized computing power, right? A computing power. Homes can transform itself into a computing power. They can run machine learning algorithms, right, in their systems. Mostly these are high performance systems, which is just used for data processing or maybe checking your Facebook or LinkedIn. Some people uses it for work. Some people uses it for running applications. But there is a lot more you can do, right? And that's the meaning of utilization of untapped decentralized computing power. How, as a community, you develop artificial intelligence models or machine learning models. You want to train your models. You need data to train the models because these models learns well if you have more data. These are models that learn from experience. So we have to give them a large data with different experience. So people with different applications, different way of functioning, they generate different kinds of data, are able to provide different kinds of experience. However, we don't have access to that data, but we can provide them this model. Okay, here is my model. This is a machine learning model. I want this to be trained. You run in your system, provide me only the outcome. I'm not interested in dealing with your data. You deal with it, okay? But you don't have to know anything about it. The application runs its own, so it's an autonomous application, right? So there are different ways we can use that. And then we have this third category, utilization of distributed clean energy sources, all right? This is a case study I will show you at the end how this can be done. We call the decentralized energy sources because we have a centralized energy resource that comes from the government. Sometimes it's also private. But what if every home becomes an energy source and then share energy each other instead of having a centralized energy source, right? That's another idea. So then the birth of this decentralized autonomous technology infrastructure, which is actually a platform, a digital ecosystem for students and industrial experts to come together and then develop models, machine learning models, different kinds of models, different applications, can put these models here, and this can be trained, right? It's a free, decentralized AI ML marketplace. So we get a large different models, large collection of machine learning models from different people, from students and industrial expert, freelance workers, right? They all can come together. Everybody earns from it because we provide a token-based incentives for these models. Based on the quality of the models, you earn more. So these are applications, right? These are interesting ideas where students can come together or industrial experts can come together and then train the models and see how capable those models are in terms of application, real-world applications. Given the accelerating pace of digital technologies and its potential to continually shape lives, business practices, and governing many years to come, it's time to act now. as a student community, I encourage all of you. But we need to understand these terms a little bit in detail. So I'll just give you a brief introduction about what is artificial intelligence, what is machine learning. We have a lot of people who probably code well, isn't it? Good in software, right? I was when I was doing my BTech though in electronics engineering. After the second year, I became very good in coding. I would say good, because I used to learn C language. It was C. We didn't have the luxury to learn C++ at that point, but we learned C. So how do you differentiate a software engineer and an AI programmer? Right? That's an important question. All software engineers are not AI programmers, but all AI programmers can be a software engineer. The only difference here is you need to know a little bit of math to be an AI programmer or a machine learning programmer. Okay? So you get that foundation as an engineering student. You learn a lot of mathematics, right, in engineering, which is very, very essential. Don't leave it off. Normally, the math professors are very abstract. They say let X is something. They don't clearly explain what that X in a real world system means to you. They say it is a variable X. But when it comes to reality, as an electronics engineer, you can imagine that X could be a data that come from a sensor. X could be a variable that come from the environment which sensed by the system, right? Well, this is a possibility. So what separates an AI from general purpose software is that it enables machines to respond autonomously to signals from the external world, signals that programmers do not directly control and therefore cannot always anticipate. Right? So that's basically the basic difference between an AI program or a general purpose software, which we all develop, right? And next, the next, machine learning. Machine learning is nothing but a system that learns from experience. It has to pass through certain phases. There are different ways to train the algorithm to learn from its experience, so it keeps the learning. And then when you face similar experience, it understands how to tackle such systems. So it's a generic definition, as I placed here, a computer program that's set to learn from experience A with respect to a class of task T and a performance P. So basically, we are trying to improve that performance P based on an experience in a task, right? There are different ways of learning. So there's unsupervised learning, supervised learning, reinforcement learning. Unsupervised learning means you have a large collection of data, different kinds of data, different types of data. Today, we have different categories and types of data, isn't it? When we study like programming, we had integers, right? A data type. Binary, a data type. But today we have a large collection of data. This is because we advanced processor designs, which makes it possible to come close enough to high-level language. So your hardware actually, in the 90s, it was a larger gap between the hardware and the software. Now the gap is being reduced. We call the semantic gap, right? Because the hardware is advanced so well, the complex architectures that comes very close to the high-level language. So programming is very easy in these days, isn't it? Because we have modern programming languages like Python, Java, C++, Julia. There are a lot of different languages that helps us to code well. So unsupervised learning means you learn from a large collection of data which are not categorized at all. It's a mix of a large and different kinds of information. Unsupervised learning basically go through this, scan through it, and then figure out similarities among them, and then segregate them and group them. And then that's how it starts to analyze it, right? But in supervised learning, it's a bit one step ahead. We just use the data that come from unsupervised learning, which is already categorized. So there are labels in it, and it's very easy to step forward from it. It's an interesting concept is the reinforcement learning, right? Which you all experienced one or the other way. Those students who play games understand what reinforcement learning is. It's an agent that is being rewarded each time when he does something, a positive reward for some action and a negative reward for some other action. So each time when he does two activities, he gets a positive reward for one action A and a negative reward for action B. So over time, he learns that I shouldn't do action B because I'm getting negative reward, it being beaten up when I do that, right? So I'm not going to do that. I'll stick with doing this action A. So you're biasing your agent to do one particular action and then allowing the other action to die itself without being encouraged. It's a dopamine system, right? When you do certain activity, your dopamine makes you happy, right? It's a reward system. I have some examples. I can show you one example here. So this is actually an example. Here, I'm just going to restart it. It's an agent which has 6 eyes, and he has given 2 different apples, okay? A green apple and a red apple. The green apple is poisoned. So when he eats a green apple, his life reduces, but when he eats a red apple, his life increases. So that's a reward. And over time, he learns that he should only eat the red apple and he should not eat the green apple. And now it is starting. You can see it is moving around and it eats both red and green at the same time. Whatever it say, because he's very hungry and he's keep eating. But when he eats a green apple, he sees that something bad happening to him, but he eats a red apple, something good happened to him. So you can see after training about 10 minutes, you can see that he only eats a red apple. He excludes the green apple. See, he's moving around the green apple, but he won't touch it. Oh, he took the red apple there, right? See, this is a reinforcement learning. So that's the machine learning. Machine learning is a study of algorithms that improve their performance at some task with experience. It optimizes the performance criterion using example data and past experience, right? Role of statistics is very important. So that's why I'm saying students don't leave mathematics, linear algebra. Learn well, okay? And blockchain. Blockchain is an interesting technology. How many of you learned linked list in your data structures, algorithm, computer science students or computer engineering students learn linked list, right? In data structures and algorithms, or maybe some similar course in your curriculum. Blockchain is kind of an extended version of that. Blockchain refers to distributed database residing on internet composed of records or blocks which are linked or chained together in a manner that resists modification, hacking, and destruction, right? There are different characteristics of blockchain. Blockchain is just a database technology. It is not a financial or not an industry application. It is a technology. A computer engineering technology, or you can say electrical engineering, doesn't matter. It's a database technology. It can be used to create and track digital representations for any type of asset, okay? Asset means real estate, right? Or any product which you have in market today. And it also not a financial technology. It is not a financial service technology, but it can be used both financial and non-financial sector, right? It can be used as well. But there are a lot of different regulatory aspects that needs to be sorted out. The governments are working on it. There is a separate society being developed in the UAE to work on these regulations. And the government of India also started seriously thinking about this. I think you heard about in the last budget about introducing a new forum which may standardize these technologies. Living in the world of digital representations, So online shopping, any online product, any product in the digital form can be digitized and create a unique digital representation of it, which also solve the double spending problem. Okay. So a lot of to learn more. It will expand the horizon of your thinking. Strength lies in transparency, immutability, and security. Core benefits includes transparency, immutability, censorship resistance. For example, movies should also be in this, so the censor board loses its job. Security and other aspects of data. Everything is interesting. The characteristics, when you study about blockchain, you will find, oh, this is the finest technology I can ever see in my life. For any area, it doesn't matter what area you come from, which area is business you're doing, or studies you're doing, right? A lot of different applications can be developed. Tremendous opportunity, endless opportunity, I would say. Students, pay attention, okay? Also, the double spend problem, because every product can have a unique digital representation, so there is no need to worry about that. Because you know that a lot of issues in the third party is no longer exist in this. It goes directly from, the customer and the product developer and the customer. So you basically save a lot from this technology. So blockchain technology is a decentralized digital ledger. You can define in that way. Industry standard high encryption, right? So there is less immune. It's very much immune to hacking and other. Then transactional trust and non-repudiation, low latency peer-to-peer transactions, which means the delay in reaching a product reaching the customer will be greatly reduced. There are public and private options. So there are different ways you can implement the blockchain technology. I just deal with few of those here. So a private blockchain is more like an internet. It's a centralized entity, controls a set of entities that can act as the readers and writers, basically readers and writers, right? Readers means anybody who is part of the chain can read every information in the chain, right? It is transparent. That's the transparency. But writers means those people who have authority to validate a chain or a block, that it is the right way to add it, because every transaction adds blocks to the chain, right? So there are a group of people which are authorized to check the validity of the blocks that's coming in and then update the system. But in a public blockchain, and any entity can be free to participate as a reader or a writer. So you are well accepted there. There are a lot of examples for public blockchain, Bitcoin, Zero Cash, Ethereum, all these are examples of public blockchain. We all can be part of it. But always a word of caution that you need to be very, very careful when you get into that, okay? Because this is a world which is very, very new. Well-educated people means well-educated in terms of blockchain technology. A good understanding is necessary when you jump into it. Because I'm not a financial advisor, so I may not be able to advise on that, but I can advise on the technology. Hybrid blockchain is a concept that's trying to combine the upsides of both public and private, because in some cases, people may have public data and private data. So we want to protect the private data, and we can use whatever that is public can be placed in public. So that blockchain technology is also in the development phase. And then there is mainly two categories, permissionless and permission. So if you come to public, permissionless means anybody can read and write, right? And permission means anyone can read, but writing is kind of limited. Only authorized people can write, means only authorized people can add blocks into the chain. In private, only authorized participant can join, read and write. Private, okay. Permissionless, private permissionless means those authorized people are allowed to read and write, but in permissioned, only authorized participants can join and read, but writing again is special authority, okay? Means adding a block, updating a block is a special authority. It's called the consensus process. It is not a single person, it's a group of people. So then we have to create a consensus among the group saying that, okay, this is a valid block which can go in and update the system. But again, there are a lot of use cases today. Financial transactions is a important sector that's being slowly transformed using blockchain technology. Energy generation and distribution, highly regulated by federal and regional regional organizations. But today it's like that, but hopefully in a few years of time, this will change with the development of renewable energy sources. Blockchain renewable energy credits or tokens that can be generated by distributed energy sources. One platform to track calculations of carbon emissions. In this case, the carbon emission tracking it also becomes very easy. Sorry. Healthcare is another area which is widely used. Data analytics, ability to track outbreaks across diverse locations. You know, this is very interesting applications that's being developed in recent days because of the pandemic, which we are all facing today. Aid in identification of outbreak hotspots, speed response times for containment, and share critical data to track community spread of disease. All these are something which you're all familiar, the words which are familiar. I'm not sure how many of you have participated in such process of developing systems for that. Also, medical research. India is home for leading healthcare research institutions, including Chennai. We have a large number of institutions there. Blockchain opportunities can act as a draw healthcare businesses within a state. So there's a lot of data being developed, being added, and this can be streamlined, make things easier for patients and doctors to prescribe and then understand that it takes lesser time to prescribe a medicine because we understand the patient's issues very effectively. So these are interesting applications in healthcare industry as well. Records management. This is another area. You know, there's an IIT Madras, there is a startup which is called Doc Wallet, which is also expanding into UAE, like they have opened an office in Abu Dhabi. Doc Wallet is a company that trying to develop a blockchain platforms to create digital representations for transcripts. For example, all students, when they write exams, you get transcripts and also you get degrees. These are like documents that's being generated and then printed and given to you. Instead of that, why don't you create a wallet, call it Doc Wallet, where these transcripts and degrees will be locked and then given a password to you, which is kind of a blockchain-based system. And these password can be shared with your, you know, if you're going for an interview, you can share it with your company where they can read these information. Which is very interesting. Many universities are working on it with these companies to create these kind of smart contracts. Very, very, very interesting platform. But there is also risk involved in blockchain technology as such because it's not very advanced today. The cost is much more. Standards, I mean, lack of standardization, lack of centralization, regulations are still in the process. Environmental impact because we require a large computing power. That's why I was talking about in the beginning, decentralized computing power, which basically solves this problem to some extent. And increasing cyber threats, you know, we need to also worry about that as well, because a lot of fraud activities that's happening in today's world, which I think to some extent blockchain tried to reduce that as well. So that's an introduction to blockchain. Now I'll talk a little bit about decentralized autonomous machine learning platform, which is basically a digital ecosystem that's being developed in AUD to support students to come up with ideas in blockchain, machine learning, and other areas of interest. So what are the content of it? Decentralized autonomous machine learning. It has an underlying platform. A networking platform is a hybrid blockchain technology, which has private and public characteristics. Development of usable and high quality machine learning algorithms and models, applications, model being trained using public and privately held data by individuals which are part of our system. So a lot of individuals being signed up in our system, and they, we use the computing power from their homes, and we send these algorithms to their home, and then we run in their system using their private and public data, and they don't have to share the data with us, the privately held data, but they can share the outcomes, which is something very interesting for students to develop models and train them in a much faster rate rather than waiting for data come from this place and that place. Waiting time is very important. We don't have much time to wait, so we can move faster with this kind of ideas. So this is an interesting sector for engineering students to take advantage of it. We can provide this platform to you guys as well if you are interested in joining AUD's decentralized AutoML platform. And that this is one of our say use case or case study I just put in here because it's a company today in AUD, a startup company we call Energy Chain or eChain. It creates renewable energy credits or tokens based on blockchain. It also has energy management unit, intelligent environment at homes to optimize the energy usage in a house. So they sell as a package, right? The reason why the students came up with this idea because UAE ramping up renewable energy for at least the energy mix around 25% of the total power generation by 2030. Because now almost 99% of coming from fossil fuel energy generated in the UAE. But we have the government of UAE has an ambitious plan to turn that into 25-75 in 10 years of time. So they are in the process. There's a lot being done actually. So students being given a lot of different opportunities. Basically, this is funded by the Expo 2020 in the UAE, this particular platform. eChain is a decentralized autonomous peer-to-peer application to trade clean energy. So anybody with a capacity to generate electricity can share the rest of the energy. For example, I have requirement of 8 kilowatt per day. I generate 10 kilowatts, so I have 2 kilowatt extra. So I can sell it to my nearest neighbor who don't have such a capacity. So this can be done in multiple ways, in a grid connected, grid with no grid connection. So all these are different way to develop the technology. So eChain basically a technology that supports energy trading, renewable energy trading from home to home, a peer-to-peer transactions. And this is linked to the bank, so there is a tariff that's being decided by the energy provider, and the tariff will be in place. Sometimes many of our customers, the homes which are participating in this process, may get a zero energy bill, a positive energy bill, right? A positive bill means they get money. Money is coming to their home instead of going to the service provider, which is very interesting. So this is done in a very interesting way. Students developed a microgrid platform and a blockchain-based technology that is completely autonomous. So we don't have to, the homeowner need not worry about whether the excess energy is sold today or it's still in block or it's going to the grid. It's completely taken care, right? This is a prototype. I just want to show the picture. The students developed this in AUD and to demonstrate the idea in the beginning, like, they have 3 houses, 2 houses with capacity and one house without a capacity. And you can see a bigger house with larger capacity, a smaller house with smaller capacity. In fact, the bigger house with the larger capacity can sell or so sell energy to a smaller house with a smaller capacity. Sometimes every house do not have the capacity to generate the entire energy requirement. So if you are interested in getting only clean energy and not interested in getting the fossil fuel energy, then you can completely depend on this and buy energy from others. So this is on your right, it shows the transaction that happens when energy is sold from one house to the other. So this is basically a real house which we constructed in our campus. You can see my team there, which also include home automation, completely run by solar energy, and it generate electricity. It is a one-bedroom house. Every thing inside the house is generated. In the entire house runs on clean energy. So that's about it. And I just briefly go into peace engineering because I mentioned in the beginning that we also deal with peace engineering. Peace engineering is actually an activity that we started with the support of UN Disaster Relief Agency. That some of our students working with UN to develop products to support countries like Sudan, Peru, and Syria, where they have the country's infrastructure being damaged due to war or natural disaster. So our students develop products to support the society and build the society. And the business need, what UN told us, is about provide a portable power management system for disaster relief and humanitarian outreach. And they have certain requirements, actually. For certain countries, solar could be a good option to generate power, but in some other countries, wind is another source of energy. In some other place, the tidal waves or on other conventional sources. So they're not very specific about what source you're going to design. Based on the geographical location, you can decide what are the different sources you may rely on to generate power. And then we've been asked to provide a communication system, water sanitation, which means purification of water, which is essential for those people who live as refugees in refugee camps. Water recovery, if there is water source available, then we recover from it. And then, so there's also systems that are being developed to generate water from the thin air. So these are different applications and low voltage applications for lighting systems, okay, and to power a computer in a house or some applications like that. So this is a larger picture of what students being working on, and to some extent these things are completed. So we have batteries and then different resources, and then connectivity, as well as communication systems being installed. So these are the sources basically that's the switching sources that switches from solar to wind based on the geographical location and which energy is more powerful there. And here you can see a portable system which has panels attached to it, and it can be moved around, to power a small house, for example, a refugee home with a single room with a hot plate and a study table with a light and a fan. This can be supported. And this is the wind turbine that's being developed to support the people in Peru because they have more wind in that location. So we developed this to support them. And here is the entire box. You can put everything in a box like this, and it's on the wheel, so you can move it around. So these are something interesting for students to come forward to build societies, because as the engineers, we have the responsibility to be part of an economic development as well, because engineers inherently part of an economy. When you develop product, when you start an entrepreneurship or develop a product as part of a company or as part of an entrepreneurship program, you're basically building a society, improving the life of people around you. So that's basically a kind of a responsibility of engineering students to come forward and participate in these initiatives. It's called peace engineering. It's just nothing but electrical engineering or computer engineering students participate. You can see like 3 students, around 5 students from my university participated, and they're very happy. They show a good picture of it here. Likewise, it's interesting to see these projects being developed, and it's a well-advanced global peace initiative for engineering. So every students are welcome. We will establish, I have a talk with your HOD. We will establish this in your place as well. Those students who are interested can work with us. So basically, that's conclude my presentation today. Digitization, decarbonization, decentralization provides a better world, and things to keep in mind. Every learning is important. Every idea is important. No idea, don't throw any ideas. Whatever you have, imagination is a key. Okay, come forward. We are here to support you. We are here to provide you the things you need to develop your idea further. So thank you everybody for listening to me today. And if you have any questions, please.
Thank you, sir. Participants, if you have got any doubts or questions, please feel free to ask it. You can also type your questions in the chat box. Sir?
Yes.
Sir, we have a question from Monica. That is, does an ethical hacker have any role in these fields?
Yes, very much, because ethical hackers, sometimes you're very useful for us to develop immutability in our systems, right? Because a lot of different way to people hack into the system. So you are very useful to us, and we have an ethical hacking club in AUD. You can join. You're welcome to join that as well. And they often participate in activities to educate other students about, how systems can be made immune to hacking. So to expand a little bit further, the technology which we are talking about today, especially the blockchain technology, try to overcome a lot of different issues in hacking, and try to secure the system. So security is an important aspect, and that's being taken into prime consideration. So yes, all hackers are welcome, whether it's ethical or non-ethical. We encourage students to learn further, but we don't encourage non-ethical hacking or any such activity. That's not what we teach as a community. We are, as engineering students, we are here to build societies, develop societies, help society to grow and improve the life of fellow human beings. Okay, and if there is a way you can help the society, build the society, and improve the life of others, you're always welcome.
Thank you, sir. The next question is from Shruti.
Yes, please go ahead with the question.
Yeah, sir, kindly explain the difference between ubiquitous computing and pervasive computing and its applications.
Ubiquitous computing means computing anywhere, everywhere, which means as you see today, you have a laptop, you have a a phone, or every system is there is a computing power. Okay, but in ubiquitous computing means you probably don't see these systems as an entity on your table or anywhere. As you walk in the sideways around you, or the place around you, whether you are in a transport center or in a metro station or in your office, you can talk to artifacts like on the table, on the walls. Systems are integrated at dedicated systems, and not be a full-fledged processor. And these systems have the ability to listen to you. Okay? And when they listen to you, they take commands from the way you talk to them. Every word you talk being translated into a program and that runs in the system and take actions based on it. So that's called ubiquitous computing or pervasive computing. And the applications today, like it does not exist in today's world. To some extent it is, means in elements of it, not a full-fledged ubiquitous computing. Natural language processing well advanced today. You have it in your phones. You can talk and then listen to it, and then it takes action based on that. You can say, the Google Assistant, it understands the language you talk to them, but it's being widely talked about. It needs to go a long way to reach the goal of ubiquitous computing, means computing anywhere, everywhere, and not as the traditional standard, but it's a non-conventional computing platform. I hope I answered your question.
Yeah, thank you, sir. The next question is, sir, kindly tell thirst areas for doing project in machine learning, robotics, and automation.
Can you please repeat that again?
Yeah, sir, kindly tell thirst areas for doing projects in machine learning, robotics, and automation.
Trust areas. Oh, okay. Machine learning has a lot of different applications. Okay, especially when it comes to data analytics. Whether you develop application in certain field, as I mentioned that it is in healthcare sector or in financial sector or in academics, or when it comes to government sectors as well. Any sector, every sector generates a lot of data. And they also have a decision-making process. So they put these data together, the people come together on a table, they decide, okay, based on this, which direction to go. All this can be automated. So there is no specific field which you are looking for, any field you're working on it. Whether it's for example, I give you this court systems, right? You go into a high court or in a Supreme Court, every day, hundreds of cases being heard. Every case has different artifacts, different facts about the evidence and non-evidence or information that relating to the case. All this can be digitized and then create an application that generate information based on the need. For example, the judge is looking for certain particular evidence and then connecting to these and this. And the court has to look for it for some time, but a click, just giving a few search means you can generate this information. So document extraction, document retrieval, all this can be applications of it. So there are millions of applications which you can talk about machine learning or artificial intelligence. Blockchain is basically a platform where you want to create digital representations of any item. For example, I gave the use case of energy chain, which is basically trading clean energy from two peers, like two homes or two business units. Likewise, and there is also transport. For example, when it comes to electric transports. Now we have autonomous transports in the UAE. We have autonomous taxis are there, which runs in a city only. Like, if you go to the downtown Dubai, you will find autonomous taxis. So when maybe in few years, these autonomous taxis may hit the highways. So there will be a track where the autonomous taxis are moving, or they're not. Every track there will be manual driver, a car with a driver, or a car without a driver. And how do you communicate the signal transmissions and all that. So there is a platform being built on blockchain to communicate between this. Like, I'm going to just change the line now for the autonomous taxi, then it needs to provide the signal, because a lot of information being transferred from face to face. For example, drivers see each other from their eyes, they talk, these informations, how these can be transferred. So all these are new entry of information systems that needs to be developed to make these world more autonomy, or provide more autonomy into the system. Is that all right?
Yeah, thank you, sir. So now I call upon Ms. Monica to deliver the vote of thanks.
Good morning to one and all present here. It's my privilege to propose the vote of thanks to this August gathering on the International Conference on Smart Technology and Applications, ICSTA 2022. First and foremost, I wish to express my sincere gratitude to Dr. Vinod Pangrashiyas for his presence. Thank you, sir, for addressing the audience through our guest lecture. We gained more knowledge about blockchain, decentralized application, cloud engineering, digital transformation, artificial intelligence, and machine learning. I thank our principal, Dr. L. Ganesan, for making these wonderful assimilations, and special thanks for your laborious effort and your great generosity for promoting this international conference. Thank you, sir. And I indebted to thank our vice principal, sir, Dr. S. Raja Karnaharan, for his constant support for organizing this conference. Thank you, sir. Next, I extended my gratitude towards Dr. K. Vijayalakshmi, organizing secretary for this international conference, who helped us in various ways to organize this conference successfully. Thank you, ma'am. My gratitude is also extended to Dr. S. Periyanagi, head of the Department Electronics and Communication Engineering, who constantly motivate us to conduct such events successfully. Thank you, ma'am. I also thank our faculty members for their tireless effort. Last but not least, my big thanks goes all the participants for their active participations in this lecture. Once again, I thank you all.
One final note to all students who are interested in participating in these kind of initiatives. AUD welcomes all of you. We have programs and policies in a way that you can participate and join our students to start initiatives. I had a brief discussion with your head of the department. You can contact your professor and collect this information and then communicate with us. We will provide ways and methods in a way that you can join teams with our students in AUD to start these initiatives. Thank you all.
Thank you very much, sir. Participants, kindly fill the feedback forms individually and you can get your certificates. Sir, shall we close the meet officially? Yeah, thank you very much, sir. Thank you all again. Thank you
very much. Wish you all a good day.
Thank you, sir.
Bye.